Hello everyone, my name is Hazik Kirmani and welcome to our new video of the same series, Most Expected Archive series, in which we discuss the IITJEE previous year problems and their beautiful solutions, and we get some insights for the upcoming questions that can be asked. Fine. And we have been given this beautiful problem that was asked in 2011. It says a train is moving along a straight line with a constant acceleration. So this is our train. It is moving with an acceleration of a. Fine. A boy standing in the train throws. This is the boy standing in the train throws a ball forward with the speed of 10 meter per second. So forward 10 meter per second at an angle of 60 degrees. So this is 60 degrees. Fine. Okay, so this is the projectile inside the train. So it will have this kind of a trajectory. Fine. Okay. It says the boy has to move forward by this much inside the train to catch the ball back at the same initial height. Okay, this was the initial height. At the same initial height here, basically, if he wants to catch it, he has to move 1.15 meter, isn't that? So he moves this much, but train also has an acceleration. The concept is, once you throw the ball, it is not having the acceleration then, isn't that? Once you throw the ball, whatever velocity you gave it, that 10 is related to the train. Whatever, if a train also has u velocity, this 10 is u plus 10 with respect to ground. Okay, so we don't need to consider the velocity of train basically. Fine, because if that is u, this is 10 plus u, so they will get cancelled after all. But what about acceleration? Acceleration is a force, okay, that can only be in contact. Fine, in this case, this kind of force, this kind of acceleration can only be produced if the bodies are in contact. But once the ball is thrown, the contact is released. Acceleration is only experienced by the man and the train afterwards. Fine, so we'll say the man has to move 1.15 meters forward. And what about the train? Train will also move. S is ut plus half of at square, because we are taking with respect to the ball right now. So that is half of at square, the distance that the boy covered, because he is in the frame of train, isn't that? Because he is in the frame of train. This is what boy has to move with respect to train, and with respect to ground he has already moved this much because he is inside the train, isn't that? And this should be equivalent to the range of the projectile. Why? Because once you throw the ball with respect to ground, there is no force exerted on it, isn't that? It is just doing its normal projectile trajectory, because this a is not applicable unless and until you study it in the frame of train. We are not doing that. In the frame of ground, man is moving this much, but his platform is also moving this much. That should be equivalent to the range with respect to ground. Fine. So, but what is the time here? Time t. So this time is the time of flight, because till the time it comes back, we are considering that time. In that time, how much the train has moved. Fine. So the time of flight is 2u sine theta by g. Basically we have done the problem now. 2 into 10 into sine 60 is root 3 by 2 divided by, for example, 10 will take it as 10 goes. So this is root 3 seconds. Fine. This is root 3 seconds. Let's calculate it now. Okay, what about range? Range is u square sine 2 theta by g, isn't that? So that is 100 divided by 10 into sine 120, isn't that? Sine 120 is cos 30, that is again root 3 by 2. Fine. This goes, this is 1, this is 5, so 5 root 3. 5 root 3 meter is our range. So can we write this equation? 1.15 meter plus half of a into 3 root 3 square basically is 5 root 3 meter. From here, if we study, if we calculate, this is, bring this here, okay, this is 5 into 1.732, isn't that? 5 2s are 10, 1 carry, 5 15 16, 5 6 are 35, 36, 5 1 5 6 7 8. So this much minus 1.15 is half of, see, I'm not using calculator because you're not supposed to use calculator in the problem. Fine, So this will come as 1 and 5 and 7, and this is how much divided. 3 into 2 is acceleration, and this is 2 ones are 2, 10, 1 e carry, 14, 15 and point. Fine, 3, and this clearly gives you nearest integer approximation. A is 5 meter per second square, and that is the answer. I hope you enjoyed this problem, and this is kind of a basic problem in projectile and relative case. These type of problems can always be expected in mains as well as advanced. So I hope you enjoyed this problem, and this question can be explored a lot because it can be elaborated. It can have many cases, many scenarios, and it can change the values as per requirement. So if you know this concept, you can solve all those problems, and I hope you try it once again yourself so that you get the same answer, you get the confidence. And I hope you like, share and subscribe so that I complete this series. Till then, bye bye.